In the desert, survival is not always about speed or strength. Sometimes, evolution writes its strangest weapons into the bloodstream itself. The Chihuahuan Desert of North America is one of the most unforgiving arenas on Earth. By midday, the ground surface reaches temperatures that would blister human skin. Water is a rumor. Shade is a luxury. And every creature here, every hawk circling overhead, every coyote padding between the creosote bushes, every rattlesnake coiled in the shadow of a rock, is, at its core, a problem to be solved. On the open desert floor, there's nowhere to hide, except for one small creature. Hiding is not really hiding at all. Meet Phrynosoma, the horned lizard, flat-bodied, spine-rimmed, barely larger than a human palm. To most eyes, it simply does not exist. Its skin mirrors the gravel so precisely that a hawk can pass within meters and see only desert floor. This is camouflage as high art. But it is only the first layer of something far more extraordinary. But camouflage is only the first line. The desert does not forgive a single solution. A coyote appears on a ridge. Its nose decodes the air from hundreds of meters away. And today, it has found something. The lizard's first response is stillness. Absolute architectural stillness. Against a hawk, this is often enough. Against a rattlesnake, the lizard's spines, sharp as thorns, make swallowing a life-threatening gamble. But a coyote is neither hawk nor snake. The coyote uses its nose. It is persistent. And so the lizard shifts, hissing, lunging, making its spiny body a difficult mouthful. This is the threshold, the moment evolution has spent millions of years preparing for. Inside the lizard's head, something remarkable is happening. Tiny muscles constrict the veins, draining blood away from the skull. The arteries, however, keep pumping. Blood continues to arrive, but now it has nowhere to go. Pressure builds inside the sinus cavities surrounding the eyes. Blood-filled chambers that begin to swell like pressurized tanks before a rupture. The coyote leans in, and then blood. A precise pressurized stream of deep red shoots from the lizard's ocular sinus, up to 4 feet through open desert air, directly toward the coyote's face. The coyote recoils instantly, shaking its head, pawing at its muzzle, retreating. The reaction is not confusion, it is revulsion. This is not panic from the lizard, this is precision. What the coyote has tasted is not simply blood. It is something far more layered. A chemical story written across millions of years of an extraordinary relationship. To understand the weapon, you must first understand the meal. Harvester ants, venomous, aggressive, and largely avoided by most desert animals. Their sting is among the most painful of any insect. Their venom contains compounds designed to deter, incapacitate, and warn. To the horned lizard, they are breakfast, lunch, and dinner. A single regal horned lizard may consume hundreds of these ants in a day. They form the overwhelming majority of its diet. And while most animals treat harvester ant venom as a threat, Phrynosoma has done something that feels, in biological terms, almost alchemical. It may be absorbing those compounds and turning them into something else entirely. A 2024 study published in Ichthyology and Herpetology confirmed that the aversive compounds in horned lizard blood plasma are linked directly to Pagonomyremex ant venom. Lizards that eat these ants carry the compounds. Lizards that do not, do not. The lizard appears to absorb the venom's chemical signature, or its metabolic descendants. and repurpose it into a foul-tasting, predator-deterring shield. This is evolution as recycling. Danger converted into protection. The hunter becomes the source of the weapon. What makes Phrynosoma truly remarkable is not one extraordinary defense, but many, deployed with something that looks remarkably like intelligence. Against a hawk, it freezes and flattens, eliminating the movement cues that trigger a strike. Against a rattlesnake, it tilts its spine-covered skull downward, making the first bite potentially fatal for the snake itself. Against canids, foxes, coyotes, domestic dogs, the blood squirt engages with near-perfect reliability. Field studies have shown that encounters with canid predators trigger the response 100% of the time, while other predators provoke far less reaction. Evolution has not written a single response to danger. It has written a library, one entry per predator, calibrated across deep time. Each defense costs the lizard something: energy, exposure, biological resources, and so the arsenal is arranged in order of cost. First the cheapest trick, then the next, then the next. With blood squirtin' held in reserve as the final dramatic act. In the desert, waste is extinction. Here is where the science becomes genuinely astonishing. A single horned lizard has been observed firing blood up to 9 times within 17 minutes, and suffering no lasting harm. The volume lost in each burst is a small, non-lethal fraction of total blood volume. The body replenishes, the sinuses repressurize, the weapon reloads. How precisely this rapid recovery functions remains incompletely understood. The exact physiological mechanisms that allow the sinus pressure to rebuild so quickly, without depleting circulation or destabilizing the animal, are still the subject of active research. This is the edge of what science currently knows, and there is beauty in that edge. In an age when nature can feel catalogued, the horned lizard still holds a secret. It squirts blood from its eyes 9 times in 17 minutes, and we are still working out how. Not all horned lizards arrive in the world the same way. Most species of Phrynosoma lay eggs buried in warm desert soil, left to develop alone. But the short horned lizard, Phrynosoma hernandesi, takes a different path. She gives birth to live young. Up to 48 offspring can arrive in a single event, each born inside a thin, glistening sac it must rupture within minutes. Fully formed, spines hardened, within hours the young are foraging, freezing when shadows pass, becoming invisible. Within a single genus, evolution has written 2 entirely different solutions to the question of how to bring new life into a world that wants to eat it. Eggs buried in silence, or small, armed, living things delivered into the sun. Both work, that is the point. But the horned lizard's extraordinary chemistry depends entirely on one thing: the harvester ant. Remove Pogonomyrmex from the equation, and the lizard loses not just its food, but potentially the very compounds that make its blood a weapon. Pesticide use, habitat loss, urban expansion, even the collection of lizards as pets, all apply pressure to populations balanced on the edge of desert arithmetic. In some regions, horned lizard numbers have declined sharply within living memory. Children who once found them easily in backyards no longer do. What vanishes first is not the lizard. What vanishes first is the ant. And then quietly, the weapon fails. And then, so does the creature. A desert ecosystem is not a collection of individual species. It is a negotiation, a long, intricate, mutually dependent argument between living things. Disturb one voice, and the whole conversation shifts. In the end, Phrynosoma survives not through power, but through precision. It survives through pressure, biological pressure, evolutionary pressure, chemical pressure. It survives because millions of years ago, some ancestor discovered that a venomous ant, rather than being merely dangerous, could be made useful. That danger, absorbed and transformed, could become a shield. It survives because evolution is not a story about the strongest. It is a story about the most inventive. In the desert, survival does not always belong to the fastest, the largest, or the fiercest. Sometimes it belongs to the strangest. And somewhere in the warm gravel of a North American desert, a small, spined, perfectly camouflaged creature carries inside its own blood one of the most improbable weapons nature has ever designed.